Today we'll be solving the differential equation y prime minus y equals 0. And to start off, we could let y equal the sum from 0 to infinity of c sub n x to the nth power. And y prime is the derivative of this, which is the sum from 1 to infinity of n c sub n x to the n minus 1 power. And from here, I'm going to re-index the series, so I want n equal to j plus 1, which tells me that n minus 1 equals j, which also tells me that j starts from 0, and that y prime is now going to be the sum from j equals 0 to infinity of j plus 1, c sub j plus 1, x to the j. But here, j is just a dummy variable, so let's replace it with n again. So y prime is the sum from n equals 0 to infinity of n plus 1, c sub n plus 1, x to the n. So now we have everything we need, and let's replace y prime minus y equals 0 with these series. So y prime, we said, is the sum from 0 to infinity of n plus 1 c sub n plus 1 times x to the n minus y, but we said y is this, so minus the sum from 0 to infinity of c sub n x to the n. And now we can combine these series into the sum from 0 to infinity of n plus 1 c sub n plus 1 x to the nth power minus c sub n x to the n equals 0. And then from here, I could factor the x to the n term. So you have the sum from 0 to infinity of x to the n power times n plus 1 c sub n plus 1 minus c sub n equals 0. So if this equals 0, then this must also be 0. So n plus 1 c sub n plus 1 minus c sub n equals 0, which tells us that c sub n is n plus 1 c sub n plus 1. And let's solve for c sub n plus 1, which is basically the next term. So c sub n plus 1 is c sub n over n plus 1. So now we just have this recurrence relation. So basically from here, we have to try to find a pattern. So if n equals 0, we have c sub 0 plus 1 equals c sub 0 over 0 plus 1. But that tells us that c sub 1 is c sub 0 over 1. Okay, so let's see, when n equals 1, we have c sub 1 plus 1 equals c sub 1 over 1 plus 1. But that's just tells us that c sub 2 is c sub 1 over 2. Oh, but we said that c sub 1 equals c sub 0, so we have c sub 2 is c sub 0 over 2. Okay, let's see the n equals 2 case. So we have c sub 2 plus 1 is c sub 2 over 2 plus 1, but that tells us that c sub 3 is c sub 2 over 3, but we said this is c sub 2. So c sub 3 is c sub 0 over 2 times 3. So let's keep going. Let's say n equals 3. So c sub 3 plus 1 is going to be c sub 3 over 3 plus 1. But that tells us that c sub 4 is c sub 3 over 4. But we replace c sub 3 with this. So we have c sub 4 is c sub 0, 2 times 3 times 4. Let's try the last one. Let's say n equals 4. So c sub 4 plus 1 equals c sub 4 over 4 plus 1. But c sub 5 is c sub 4 over 5. But we replace it with this one. So c sub 5 is c sub 0 over 2 times 3 times 4 times 5. And I can see the pattern here. So if we keep on going, then we'll see that c sub n is c sub 0 over n factorial. So here you could see the pattern. So with this in mind, now we could say that since y, our goal is to find y, it's the sum from 0 to infinity. We define it to be this way, c sub n x to the n, but we found c sub n, so therefore y is the sum from 0 to infinity of c sub 0 over n factorial x to the n. This is equal to c sub 0, the sum from 0 to infinity of x to the n over n factorial. But we recognize this power series, it is just e to the x. So we have c sub 0 e to the x. So therefore, y equals c sub 0 times e to the x satisfies y prime minus y equals 0, where c sub 0 is any real number. And that is the final result. Thanks for watching.